So today's objectives is finding an equation of a linear model. Example 1. According to a poll performed by National Consumer League, people are more concerned about privacy issues than about healthcare, education, crime, or taxes. The percentage of Americans of various age group who consider their home address to be personal information are listed in table 5. First thing they want you to do is construct a scatter plot. There's one thing you can do. You can definitely practice your scatter plot. If you don't remember it, that's fine. You can also do it by hand. I'm going to do it by hand, and I'm also going to show you guys and refresh your memory to do a scatter plot on a calculator. So I'm gonna pause the video and you can check back. Scatter plot I have that I got off the calculator or plotted by hand, it should look like this. So this is the graph I have right now just by plotting all the points. Now I'm gonna show you guys how to do it on a calculator. Now don't forget, because the age determines the concern, so age is going to be your X value and Y is going to be your percentage. The age group, of course, we cannot put in as an age group. So what we're going to do is we are going to use age used to represent the age group. So we're going to use the X is the 21, 29.5 and so forth. And the Y is going to be 84, 80 and so forth. Here's the calculator part. We are going to do a scatter plot right now. And to do the scatter plot, what you're going to do is you got to enter the list. So go to the stat and then you are going to add it, making sure everything is clear, going up to L1 and clear, press enter. That will take care of that. And then make sure you go to 2 and press clear and enter. That will clear it. So go back and enter 1. And then we're going to enter the numbers for both list 1 and list 2. And while you guys doing that, I'm going to pause the video. I'm going to show you guys that I typed it in. So go to stat, and then when I went to edit, those are my numbers that you're supposed to have it. So now we're going to graph it. If you just remember, if you just do zoom and zoom stat, number 9, press enter. How come we don't have anything? We just have line instead of scatter plot. That's definitely a problem. So we're going to troubleshoot. Now, first of all, did you turn on your stat plot? So let's go to second stat plot. The stat plot is off. We need to make sure that's get turned on because we have been turning it off so it doesn't show up in our graphs. So now what we're going to do is we're going to do 1 and turn it on. One thing is make sure, because the number you enter is list 1 and list 2, and that's X and Y. If you didn't enter the proper spot, you got to make sure you change your L1, L2, and that's underneath here. And then, so this is a scatter plot button, so we're going to make sure that's on. We can do all kind of stuff. And we want to have a little open box or plus sign or dot. I like the open box so I can see it. Done, press enter, and then second quit. Let's double check. It's turned on. Go back and do zoom, and then do zoom stat. Number 9, there's our dots. Now, why is that line still there? Well, the reason the line is there is because under y equal, we used to have lines in there. So if you don't want the lines there, clear them. Zoom again. That's how you do the scatter plot. Just show you how to do it on the calculator. Make sure you double check you know how to do that. Describe the 4 characteristics of the association. There's no outlier if you look at the graph. The associate is linear, kind of has a straight line. It's strong. Yeah, it's kind of strong, but it's negative. Now, eventually I'm going to show you guys why is it strong or not very strong. So just give me a minute. Let's write down describe the 4 characteristics. I'm going to write it down. So now one more thing I want to show you. Why is this association very strong? I've been telling you guys all along, but we will talk about why is the association strong also. Now, another thing I'm going to show you guys. What they are saying here, find an equation for a linear model that reasonably describe the data. We just entered the data. And because we just entered the data, calculator can actually help you to create the information on writing an equation. Now, because this is a linear model, it's going to be in the form y equals mx plus b. And on the calculator, you're going to get y equals ax plus B. I'm going to pause the video and show you guys how to do it on the calculator. Figure out how to write an equation based on the data we just entered. Go to stat, okay, you are going to calculate and you are going to look at the linear regression. Oh, there's also the AX plus B. So that is the one you're going to press 4. And then they're going to calculate it for you. Now, if you have a different set of lists, you need to make sure you enter that too. But right now, you have everything in 1 and 2, so they will grab the 1 and 2. So here it tells you y equals ax plus b. So your A is equal to negative because it's coming down with a negative slope. And then that is going to be negative 0.4311. So we're going to round that to 2 decimal places. And then B is 92.85. We're going to round it to 2 decimal places. And there's something very interesting. This is the correlation, but this is R squared. We're not going to use that. That's R. So we are going to use that. And if you guys remember, if it's closest to 1, doesn't matter coming through positive, negative, it is strong if it's closer to 1. So since this is a negative 0.98, if you round it, it's going to be negative 0.99. That means this is a very strong correlation to a line. So that's why this you can write down is very close association, okay? Very strong association. Now, some of you guys, when you press, you might not get the R, so therefore you need to turn on something. Now, if you need to turn on something, this is something that you'll have to do. You need to go to second catalog and scroll down to diagnostic. You are going to have to turn it on, your diagnostic. So turn it on, press enter. Then that will make sure that R squared and R is going to show up in your calculator. And you should have it done. If you don't do that, your R is not going to show up. So please, please, please make sure that you turn on your diagnostic. And then now you can get your correlation to answer your question about the number closer to 1 is going to be a good association or negative 1. If the answer is closer to 0, it's going to be like scattered everywhere. We are going to talk about A and B, and then we jot down those numbers and I'll tell you how to write your equation. The calculation we just did, finding A and B, which is M and B, we are going to use those numbers to write my equation. I'm going to write down my A is going to be, and that is the equation I just got off my calculator with all the numbers and with rounding. 2 decimal places is all I need. Now going on to answer next question. So that is the equation describe all the points that can be the closest line to all those points. All right, D, use the model to estimate what percent of the 25 years old would consider their home address to be personal information. Now don't forget your age is your X because they are independent, and your percent is your Y. So what we're going to do is, since it's 25 years old, we are going to plug it in. So it's Y equals negative 0.43 times 25 years old and work out plus 92.85. Okay, I'm going to pause and write down all the information. So for the problem D, I show you the work. You pretty much just saying, okay, I'm going to plug into 25 years old where the X is because that's the independent variable. And then calculation, and then it's about 82.1%. So approximately 82.1% of the 25 years old Americans consider their home address to be personal information according to the model. Researchers compared the mean sulfur dioxide and air pollutant concentrations and the mean deterioration rates of marble tombstones in 21 U.S. cities for period 1893 through 1993. These data are represented below in table 6. Each row has a data for a different city. Not that microgram UG is equal to 0.000001 grams. What you guys have to understand is in this table, what is your X and what is your Y? So the mean sulfur dioxide concentration is going to cause the deterioration of the tombstone. So you should understand what is your X, what is your Y. So before we do anything else, let's talk about mean sulfur dioxide concentration is your X, mean tombstone deterioration rate is going to be your Y. So I need you to enter that, okay? So they even tell you on the bottom said, let S be the mean sulfide dioxide concentration and D be the mean of the deterioration rate of the marble tombstone, both same city. So please enter your data right now. Try the problem, talk about your association, calculate your R, find the equation to the model to describe the situation. So that's y equals mx plus b. Make sure you go to your stats and do linear regression. Answer some of the question. Let's come back and discuss a little bit more. I'm going to pause the video and finish the problem. Here are the answers for number 2. Everything in calculator, and there was no outlier if you look at the picture, and the R was about 0.90, confirms that association is very strong. The association appeared to be linear. It's kind of like a straight line because its correlation is about 90%, and then strong, and then it's positive. Going on using the same set of data in y equals 0.008593x plus 0.332, and so that will be my equation of the whole situation, and that's by using first var, VAR, and go into number 4 with AX plus B. Then I use that equation because sulfur dioxide concentration was 150 Ug slash meter to the cube. Sulfur dioxide is going to go in as X because that's how much sulfur dioxide in the air that erode the tombstone. So that's going to be the X. And when I did my calculation, I'm punching the calculator, is about 1.6. Answer is, so the mean tombstone deterioration was 1.611 millimeter according to the model. So that's how much it deteriorate. Then D, it says the city mean deterioration of the marble tombstone. So tombstone is getting smaller and being eroded. Is 2. Now asking the question a little bit differently, this is now the Y, because Y is how much the tombstone eroded. So I plug in the 2 and solve the equation, solving for X, and that is saying that the carbon sulfur dioxide concentration in that city was about 195.28 Ug/m per meter cube. In this lesson, we will model real-world situation and solve using a system equation now. Before we do write one equation, we analyze that. Now we're going to do 2 of them, setting up equations and then finding the intercept, which is we talked about last time. The price, example 3, the price of a product A was $20 in 2005 and has been increasing at a consistent rate of $5 a year. So this is $5 per year kind of thing. So by reading that increasing $5 per year, you should understand that probably is your slope. Okay. Then the next one, it reads, the product B was $50 in 2005. It has been decreasing at a consistent rate of $1 per year. When will the price of the product be the same? Usually the last sentence tells you what they want you to do right here. So they want you to find when will the price be the same. When means time, and the price the same, equal to each other. So what you're going to do is when the time determine the price. So what we're going to do is you should understand X is going to be your independent variable. So that's what I'm going to put down is the year. And if you understand time, that's totally okay too. Next one is response variable, and that's Y. So that's going to be the price. So now let's read the first equation, right set of equations. The price of the product A was $20 in 2005, and it has increasing, that means going up, at a rate of $5 per year. So you should know that's Y equals starting point is at 20. So that's your B. So that's 20. And then plus your slope. Slope is increasing, so therefore it's going to be positive. So that's going to be positive per year. So that's going to be 5x. X is how much time? Year. Okay, so that's the first equation. What does the slope mean in the context of the problem? That means it goes, the product A increasing the price by $5 a year. So now what I want to show you guys is how to put those two equations into your calculator. So if you put it in your calculator, the first equation, make sure everything's cleared out. Make sure nothing is on the bottom because those kind of funky things will show up. So what you're going to have is one, you're going to have to enter. It's going to be 20 plus 5x. That's the first equation. Or you can do 5x plus 20. The next one is 50 minus 1x. Or you can do negative 1x plus 50 because it has $50 and then goes down by $1 a year. So now what you're going to do is you're going to graph. Now there's a couple other buttons I'm going to show you. So if you press graph and you have something like this, that's fine. Okay, but if you don't have something like this and you just have things like zoom standard, you try that. That means it will bring you to 0, 0, and 10 across on each side and up and down. So if you do zoom standard, you only see one line. And then since you only see one line, what are you going to do? So what I'm going to do is I'm going to try zoom fit. Now zoom fit means it will get the graph what you want to look at into probably the screen. So let's try that. Ah, there it is. You can actually do the calculation, or you can even, another real cool button I love you guys to know is you have such a thing called the zoom box. And if you have the zoom box, it's really cool. If you press 1 and press enter, you will see a little flashy box. That box tells you where do you want to capture. So if you just keep on moving up and down, you can actually capture where you want to see. So if you want to see it like there, you can get it and you press enter, it will give you a much close picture. Now, because we are doing calculation of intersection, we don't really have to because tracing it is just too hard. So what we're going to do is what we did before. We're going to do second calc, and we're going to do intersect, which is the last time. Press enter. First curve, say yes. So press enter. Second curve, oh, look, they flash a different line. Press enter. And then guess. Yeah, I want you to guess where they intercept. There is your answer. So the x is 5, y is 45. So there's a couple buttons I also want you to know. I want you to know your zoom box. Zoom in means getting closer. Picture makes bigger. Zoom out means you get picture smaller. And you have a zoom standard. That's a 20 by 20 space to look at. And then you have a zoom fit. Okay, so those are more buttons, you know what to do. The answer we have on the graph is going to be, oh, they lost that already. So I believe it's 5 and 45. 5 is the x and y is 45. I'm going to stop the video on the calculator and then answer the rest of the question. C. Graph using technology to determine the point of intersection. 5, 45. What does those order pair means? So in this case, in 5 years, well, in 5 years means 2010, the price will be the same, and that price is at 45. So what I'm going to do is I'm going to stop the video and write that down. Letter D is going to be what does the intersection mean in the context of this problem, which is why I said to you before. X represent the year, which is the time, and Y represent the dollar amount that will be the same for both product. So in this case, since we start at 2005, you have to add 5 years. So that will be 2010. So in 2010, product A and product B will be $45. Will both be $45. Thank you so much for watching.